Hi class, this is Professor Smith. I'm going to be doing a movie on discrete probability distribution basic. In this example, we're asked to fill in the probability that the random variable x takes on particular x values in the table below to give a legitimate probability distribution for the discrete random variable whose possible values are -1, 2, 4, and 5. In order to fill in this table, we must employ two rules about probability distributions. The first is that each of the probability values for the random variables must be numbers between 0 and 1 inclusive. And to have a probability that the random variable is equal to 0 means that we have the probability that the event, that we know that the event is impossible. That gives us a probability that it's 0. So you say, well, what could be an impossible event? So let's consider that we had a bag of marbles. 5 of them were black and 5 of them were red. It turns out if I ask you, what's the probability of pulling a blue marble? Since they're only black and red, the probability of pulling a blue is impossible. Hence, the probability would be 0. Now, if they were all black marbles, and I ask you, what's the probability of pulling a black marble? It would be 1. It's certain you're going to pull a black marble because that's all that's in the bag. So those are the cases where you have the extreme. Other than that, they're going to be values that are between 0 and 1. The next rule about our probability distribution is that the sum of the probabilities must equal 1. So if it's a legitimate probability distribution, these values must sum to 1. So you said, well, how can I find those two values? So let's go ahead and take a look at the values that they do give us, and I'll label them with a red box. So they give us 0.27, which is associated with the random variable -1, 0.19 associated with 4, and, 0.27 associated with the random variable 5. So when we add up those values, that will tell us that we have the probabilities, but I'm not going to give us 1. Well, that's not true. Let's add up the values and see what we get. If they did give us 1, the other missing ones would have to be 0. So we're going to add up 0.27 plus 0.19 plus 0.27. And when you're entering the values in the calculator, if I didn't type those zeros preceding the decimal place, you would still get the same value. So you get 0.73. So we know that the values that we have so far are 0.73. So that means that the remaining variables must equal something. When I sum it with 0.73, that gives me 1. So let's do those in a blue box. So I know that the probability associated with with 2 is missing, and the probability associated with 6 is missing. So those two blue boxes must be evaluated. And we know that the sum is 0.73. So we're going to subtract 0.73 from 1. So on the Alex calculator, I have 1 minus 0.73, which gives me 0.27. That lets me know that the two blue boxes must add up to 0.27. So I've got to figure out what values will work. What are the two values that when I add them together is going to give me a 0.27? Oh my goodness. Oh, that's too funny. Let's try that one more time. All right. Well, it turns out there's many values that can add up to 0.27. In fact, there's infinite. But we just want any two that will work. So I can take 0.07. So 0.07 and 0.20. Or you can write it as 0.2. Oops, I accidentally wrote minus. So 0.2, those will work. They add up to 0.27. You could also put in 0 and 0.27 because those add up to 0.27. You can do 0.23 and 0.04 because when you add 23 cents to 4 cents, that gives us 27 cents. So as long as all those probabilities add up to 1, that will work. So the first step we did was we made sure that we added up the values that they did give us. That gave us 0.73. Subtracted it from 1, gave us 0.27. And then we found any two values that added up to 0.27. So let's check our answers. And we see that we have it correct. So let's do one more. So I'm going to add up the missing values. So 0.28 plus 0.28 plus 0.25. And this time I did not write the 0, and you get 0.81. I'm going to subtract that from 1, and I get 0.19. So I'm going to do 0.10 and then 0.09. Notice that each of these probabilities are numbers between 0 and 1. So I hope this movie on discrete probability distribution basic is helpful.